my name is Unglaub, and this is mole ratio method. The mole ratio method is sometimes referred to as the Yoe-Jones method. And essentially what this method is you prepare a series of solutions in which you take, for one of those solutions, for example, the reactant, one of the reactants to be constant while you vary one of the other reactants, and then you measure the absorption of light, the absorbance of the solution as a function of the ratio of reactants in that solution. So, if this is the ratio, and you plot the absorbance of the solution as you increase one of the reactants in a given solution, you will see a rise or increase in the absorption. But as you keep increasing one of the reactants, you're going to reach a threshold where you ultimately end up at the combining ratio. And you can either have flatlining behavior or a decrease in the slope. So in order to calculate what that ratio is with the data, you simply look at the asymptotic behavior on either end, and where it meets, that is the value of the ratio for the solution you're examining. And you can do this, as I said earlier, for a series of solutions. So these are two different complexes, and this particular complex would have a ratio of approximately 1.5, and this complex would be approximately 2.5. Normally, though, you would be considering an integer number of the ratio. So just for the purposes of this example, this is how the mole ratio method works. You just increase one of the reactants in a given solution while keeping the other reactant constant, and using a spectrometer, you measure the absorbance and see where the two asymptotic behaviors join up. My name is Unglaub, and this is mole ratio method.